Welcome everyone to this Kinematics classical mechanics course, and today we'll be dealing with average speed and velocity. So let's get started. We have studied two physical quantities. Look at distance and displacement. Now, if I want to express speed in pure mathematical form, then speed is the change in distance upon change in time. So speed is delta, we call the symbol delta. So speed is equal to delta d, where d is speed, upon delta d, where the symbols delta d stand for distance, change in distance, and delta t stands for change in time. So what does speed tell us? Quantitative. This is the quantitative expression for speed, but what is speed qualitatively? So what do we actually mean by speed? Speed is a change in distance over a certain period of time. So it is the measure of how fast a body is changing its distance. For example, I have an object here. At times, say I start measuring time from here, so right now, according to my watch, the time is 0 seconds, so it's here. And the position of this particle from, say, my house is 5 meters. So this particle is 5 meters away from my house at time t equals 0. Now, after 10 seconds, t is equal to 10, after 10 seconds, this particle reaches somewhere here. Let's say 15 meters away from my house. So now I want to calculate the speed of this particle. The speed, as we just saw, is given by delta d upon delta t. In physics, we represent the change in quantities by this triangular symbol, which we call delta. This is the Greek alphabet. So speed is equal to delta d, which is the change in distance. Remember, it's not the distance. It's not that you just put 15 here and get the answer. No. It's the change in distance. What do you mean by change? By change, we mean final minus initial. So we take the final value, we subtract the initial value from that, and then we get the change. So the change is 15 minus 5. And then delta t, we get 10 minus 0. Then finally, the speed we get is 15 minus 5 is 10. 10 minus 0 is 10. We get speed is equal to 1 meter per second. Meter per second being the unit of speed. So that is speed. Let's get some more examples going on. Suppose there's a particle here, camera, here, and then goes from here to, say, here, at this point. And the length of the path followed by the particle is this length. Say that this length is 50 meters, right? Now, we want to take the speed of the particle when it completes these 50 meters in, let's say, 10 seconds. So we do the same thing. It travels 50 meters. So the speed is equal to delta d upon delta t. And delta d is 50. Delta t is 10. and we get the speed as 5 meters per second. Isn't that cool? So what does speed mean? We got this 5 meters per second. What does this quantity stand for? This quantity tells us that the particle is traveling 5 meters every second. It's traveling 5 meters per second. So every second it's going forward by 5 meters. So first of all it was here, then after a second it was here, here, here. And that's what it is. Let's come to velocity. Pretty much the same as speed, just the difference is that speed is delta d upon delta t, and this is delta s upon delta t. What does delta s stand for? Delta s is the change, is the displacement. It's not a change, it's the displacement. Or the change in position. Displacement is the same as change in position. We have studied that. And delta t, well, the usual meaning, change in time. So it's pretty much the same as speed, but velocity is the change in displacement, or it's the change in position or the displacement upon time, change in time. So let's do an example. There's a particle here. It travels this distance to this particle here, this point here, this point A and this point B, and the length of this path, say that length is 20 meters, and the distance between A and B, like not the distance, the displacement AB is equal to 10 meters. The actual displacement, not what the particle has covered. The particle has gone from here to here, covering 20 meters. But the displacement, the difference in position of B and A is 10 meters. And the particle takes a good 5 seconds to travel this distance and this displacement. So what is the speed in this case? The speed is delta d upon delta t, or the change in distance. So we got 20 meters, and that's in 5 seconds. So 5 is equal to 4 meters per second. So the particle is changing its speed, is changing its position by 4 meters per second. Now for the velocity won't be the same as speed, because velocity is equal to change in position. And the particle, let's say that this here position was 0 and this here position was 10. The change in position is nothing but 10 minus 0. 10 change, final minus initial, 10 minus 0. So 10 minus 0, I think you guys cannot see that. Let me erase this. So yeah, velocity is equal to 10 minus 0 upon the time. Time taken is 5. Is equal to 10 upon 5, which is 2 meters per second. So we got the speed as 4 meters per second and the velocity as 2 meters per second. So as we just saw, the speed and velocity can vary. Now, a very interesting thing is that the speed is same as the modulus of velocity. The speed is the modulus of the velocity vector. So say that my velocity vector is 3x plus 4y, then my speed would be the modulus of this quantity, which is square root under 3 squared plus 4 squared, which is just 5 meter per second. Let's do it in meter per second. And yeah, that's pretty much it. Thank you guys for watching till the end, and I'll see you in the next vid. Thanks.